14 from the AMC 2020 or 2025 AMC 12A. Points F, G, and H are collinear with G is between F and H. And the ellipse with foci at G and H is internally tangent with the ellipse with foci at F and G. So this point G here is the focus of both this ellipse and this larger ellipse. The two ellipses have the same eccentricity E, and it's a good thing they tell us what an eccentricity is because I really didn't know that during the test. And we also know that the ratio of their areas is 20-25, and immediately that tells us that the ratio of their sides is going to be 45 because we just square root 20-25 for the ratios of the sides. And they give us what an eccentricity is, and we want to find what the value of this eccentricity. So let's try to figure out some equation. So I'm just going to call everything that's related with this larger ellipse, larger ellipse, it's going to be E1. Well, I guess the eccentricities are the same, so we don't really need that distinction. That's supposed to be an eraser. But it's going to be E is going to equal C1. Equals C1 over A1 equals C2 over A2. And so C2 and A2 are going to be the values from here. And we know that C is the distance from the center to a focus. So let's just draw on the two centers. This is going to be the center of this one, and this is going to be the center of this one. So C1 is going to be, say, this distance right here. This is C1. And C2 is this distance right here. This is C2. And 2A is the length of the major axis. So A1 is going to be this entire distance, which is half the major axis. So this is A1. And similarly, if we were to do this all the way from here to here, that's going to be A2. So now we want some equation. And what we can find is, since this G is a focus to both of these ellipses, we can use this sort of G to make an equation. And the specific equation that I'm going to make is, let's just consider this line right here. That's not a very straight line, but let's consider this line right here. And maybe you'll use a different color. So this. And specifically, I'm only going to consider the things that are G and onward. Because what that is, well, this is the distance. This is C1. And this entire thing is A1. So let's call this some point X right here. Right? So we get that GX is going to equal A1 minus C1, because this entire thing is A1. This thing is C1, so GX is equal to A1 minus C1. But GX is also equal to something else. If we look at this smaller triangle or smaller ellipse here, this is A2, and well, this entire thing is actually A2. And so now we just want to find what this thing is in terms of the smaller triangle or smaller ellipse. So this entire thing is A2, so it's going to be A2 plus something, and that something is going to be what's in here. And so this, again, we know this is A2. We know that this is just C2, so I guess we didn't even need to know that this is A2 because this is C2 right here. So it's A2 plus C2. So this is our equation, A1 plus C1 equals A2 plus C2. But we also know that because the ratio of their areas is ratio of their side lengths is 45, A1 equals 45 A2 and C1 equals 45 C2, because that's just the ratios of their specific lengths. And so it's not technically a side length, but it's still a length inside of this shape, so we can still use the 45. So since we have this equation, so we can literally just plug it in. So we get A1 is 45 A2. So we get 45 A2 minus 45 C2 equals A2 plus C2. So we get 44 A2 equals 46 C2. And I'm going to divide both sides by 2. I'm going to get 22 A2 equals 23 C2. And now we want to find the eccentricity, which is equal to C over A, which is also equal to C2 over A2, because that's just kind of how we defined it here. So we have an equation for the ratios. We just need to find C2 over A2. So dividing both sides by A2 and 23, we get C2 over A2 equals 22 over 23, which is answer D.